Acids and bases are both what make up the pH scale. Acids will be found in pH levels from 0 to 7, while bases will be found on the scale from 7 to 14. When acids break up in water, they form hydroxide. On the other end of the scale, bases break up in water to form hydronium. As hydronium concentration increases, pH value decreases. The opposite goes for hydroxide. A substance can't be acidic and basic at the same time because of acid and base purpose. Acids donate hydrogen ions while bases only receive them. This is known of as the Bronsted-Lowry theory. Any acid that dissociates 100% into ions is a strong acid. An acid is called a weak acid if it doesn't do this. Some strong acids are hydrochloric acid, hydrobromic acid, hydroiodic acid, perchloric acid, chloric acid, sulfuric acid, and nitric acid. The same rules apply for bases. Some strong bases are lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide, magnesium hydroxide, and calcium hydroxide. There are very few strong acids or strong bases, as it is difficult to find 100% ionization. There are many weak acids, such as acetic acid, phosphoric acid, hydrofluoric acid, and oxalic acid. There are also many weak bases, such as ammonia, alanine, ammonium hydroxide, and methylamine. The concept of equilibrium is needed to understand weak acids because of the partial dissociation of ions that creates an equilibrium. I made a pH indicator to give some examples of acids and bases. The Windex contains a high amount of ammonia, which puts it as a base at about 10 on the pH scale. Ammonia can act as a base or an acid, but it is most commonly a base as it dissolves in water to form ammonium hydroxide. The pine sol floor cleaner proved to be very acidic as it turned pink. Pine sol is made up of pine oil, which is a very acidic substance. The Clorox bleach showed to be very acidic at about 3 on the pH scale. Commercial bleach is commonly a base, but the bleach I chose to use proved to be an acid when the indicator was added. The detergent proved to be close to neutral, but was more on the acidic side of the scale when the indicator was added. Detergents are commonly bases, but this one was filled with a more acidic substance. Detergents can often vary from basic to acidic. Adding the Windex to the pine sol created a very basic substance at about 13 on the pH scale. This is due to the strength of the ammonia as a base. Adding the detergent to the Windex created a neutral substance. The two were almost complete opposites on the pH scale, and the mixing of them proved that. The products of the equations shown are products of a double replacement reaction. In equations like this, water will always be a product, and the NaCl is what remains after water is created.